All right, let's dive right in. Today, we're looking at an awesome, real-world case study from the SRE team over at STC Lab. They published this on the CNCF blog, and it's all about tackling a problem a lot of us face, but they're doing it at a truly massive scale.
So what kind of scale are we talking about here? Millions. Yep, millions of concurrent connections hammering their SaaS platforms at any given moment. That's the kind of traffic that doesn't just need good code, it needs a rock-solid infrastructure and some serious control.
And that really brings us to the core question, the big challenge STC Lab had to solve. How do you manage that sheer volume and do something as complex as fighting off malicious bots in real time? Well, their answer, and the star of our show today, is Istio. So first up, let's talk about this high-traffic challenge. To get the stability they needed, STC Lab went with Istio. So let's just do a quick breakdown of what Istio actually is, and more importantly, how it works under the hood. Okay, so think of it like this. Istio isn't the thing doing the work itself. Istio is the brain, the control plane that tells all the little Envoy proxy workhorses what to do. And these proxies, they sit right next to your applications. This setup, it gives you the best of both worlds. You get these really elegant high-level rules for day-to-day stuff, but you also have this powerful backdoor, the Envoy filter, that lets you get your hands dirty with Envoy's raw configuration when you absolutely need to. As you'll see, STC Lab uses both. A lot. All right, let's get into the first big problem they solved, figuring out a user's real IP address. For any kind of security, especially bot fighting, this is non-negotiable. You have to know where your traffic is actually coming from. But as you're about to see, it's not nearly as simple as it sounds. And here's the snag. When you're running at scale, you're using something like a network load balancer. The trouble is, that load balancer terminates the user's connection and starts a new one to your back end. And in that little switcheroo, the original client's IP, poof, it's gone. It gets replaced with the IP of the load balancer itself, which is pretty useless for security. And this quote from the team just hits the nail on the head. For them, this isn't some minor annoyance. Losing that IP address directly cripples their main product. Their bot detection just stops working effectively. So yeah, the stakes for solving this were incredibly high.
So how did they fix it? This is where that powerful Envoy filter comes in. They used it to turn on something called the proxy protocol, which basically lets the load balancer pass along the original IP. But here is the really smart part, the security move. They decided to trust one header and one header only, Envoy external address. Why? Because unlike other headers that a hacker could easily fake, this one is set by their own trusted Envoy proxy. It can't be forged. Game changer.
Okay, great. We know who the user is. Now for the next question. Should we even let them in the door? How do we lock down internal services that should absolutely not be public? For this, they use another piece of Istio called an authorization policy. Those internal tools, right? Like API docs, admin dashboards, stuff you only want your own team to access from the office? Well, with this, they can create a super simple and effective IP whitelist. The rule is basically deny everyone unless your IP is on this specific list. It's just a really clean and powerful way to secure your internal endpoints. Let's move on to routing. Once a request is inside the system, where exactly does it go? This is really important for services that hold on to some kind of state, maybe like an in-memory queue. You need to be sure that related requests always land on the same pod.
Now, STL Lab actually uses two different strategies, which is pretty cool. On one hand, for services that demand absolute consistency, they use what's called query parameter routing. This means the client application itself literally tells Istio, hey, send this request to that specific pod. It gives them total control, which is amazing for debugging or carefully migrating users one by one. On the other hand, for services that are a bit more chill, they use consistent hashing. They just tell Istio, look, any request with the same user ID in the header, just make sure it always goes to the same backend pod. It's way more automatic and simpler when you don't need that iron-fisted control.
Okay, traffic is flowing, things are being routed correctly, but we all know that in the real world, things go wrong. Pods fail. You need to deploy updates. How do you handle all of that without dropping a single user connection? This is where Istio's resilience features are just fantastic.
So they use a feature called outlier detection, which you can just think of as a smart automatic circuit breaker. Here's how they set it up. If any pod returns 5 server errors in a row, bam! Istio automatically ejects it from the pool of healthy pods. It's put in a 30-second timeout. And here's the critical safety net. Istio will never, ever eject more than half the pods at once, which protects the entire service from collapsing. In fact, they said during a recent incident, this feature spotted and removed a crashing pod in just 50 seconds. No human had to do a thing. That's huge.
And what about planned downtime, like during a deployment? ST-Cloud has connections that can stay open for more than 10 minutes. If you just kill a pod during an update, you're going to have some angry users. The key is this graceful shutdown sequence. Now here is the golden rule you have to remember. Your Kubernetes grace period has to be longer than Istio's drain duration. See here? They give connections 600 seconds, that's 10 minutes, to finish gracefully. But they tell Kubernetes to wait 660 seconds before it gets impatient and forcibly kills the pod. That 60-second buffer is the magic that guarantees zero dropped connections during their updates.
So we've seen all these powerful features, but what did the team at STC Lab actually learn from running all this in the wild at production scale? Let's go through their hard-won wisdom. These are the lessons from the trenches.
This right here is pure gold. First, they say to start simple. Walk, don't run. Don't just turn on every feature on day one. Only add things like MTLS encryption or distributed tracing when you have a clear reason to. Second, watch your metrics. Envoy can produce a tidal wave of telemetry data. If you're not careful, it can literally crush your Prometheus server. You have to tune it. And finally, that Envoy filter we keep talking about, handle it with care. It's like a superpower, but it's also a bit fragile, especially during upgrades. It needs tons and tons of testing.
So what's the bottom line? For the team at SCT Lab, it's this. Yes, Istio has a learning curve. It's not trivial. But for their kind of high-traffic, high-stakes platform, the incredible fine-grained control you get over security, routing, and reliability is absolutely 100% worth the investment. And really, that's the perfect question to leave you with. After seeing all the power and, yeah, some of the complexity we just walked through, take a look at your own services. Is this level of granular control something you actually need? And is it worth the investment for your team and your platform? Something to think about. That's all for this one. Thanks for joining.